In this video, we will solve a minimization problem. The question is the solution to minimization problem, that is minimize y is equal to x1 plus x2 subject to the constraint 1 minus under root x1 minus x2 is equal to 0 is options are being given. We need to find out the correct option here. Okay, so what is our question? We have to minimize y is equal to x1 plus x2 subject to the constraint that is 1 minus under root x1 can be written as x1 raised power 1 upon 2 minus x2 is equal to 0. Okay, so we will form the Lagrange's function first. To form the Lagrange's function, what we do, we multiply the constraint both sides by lambda. Okay, so we have lambda times this is equal to lambda times 0, which is 0. Then we form Lagrange's, which is equal to the objective function, which is x1 plus x2. Then we add this resulting constraint, that is plus lambda 1 minus x1 raised power 1 upon 2 minus x2. Okay, to find out the optimal values of x1 and x2, what we do, we partially differentiate this Lagrange's function with respect to x1 and x2, solve them simultaneously then, and set them equal to 0. So that means L subscript 1 means the partial derivative of this function with respect to x1. Derivative of x1 is 1. Then here the derivative of x1 raised power 1 upon 2 is, it becomes 1 upon 2 x raised power minus 1 upon 2 by power function rule. If we have x1 1 upon 2, its derivative is 1 upon 2 becomes coefficient x1 and exponent is subtracted by 1. So 1 upon 2 minus 1 is minus 1 upon 2, and here we have negative sign, here will be also negative sign. So we have derivative of a constant is 0, derivative of this comes out to be minus times, first we have lambda 1 upon 2 x1 raised power minus 1 upon 2. Then L2 means the partial derivative of this function with respect to what we call x2 this time. Okay, so derivative of x2 is 1, derivative of x2 is here 1, so we are left with minus lambda only, and we set it equal to 0. This also set it equal to 0, and let us rewrite it. So we can write 1 is equal to lambda 1 upon 2 x1 raised power minus 1 upon 2, and here in this equation 1 is equal to lambda. Okay, then we need to differentiate with respect to lambda. Okay, so derivative of lambda is 1, we are left with 1 minus x1 raised power 1 upon 2 minus x2, and we set it equal to 0. Let us say this is equation first, this is equation second, this is equation third. Now dividing equation 1 by equation 2, so equation 1 by equation 2, we get 1 upon 1 is equal to lambda times 1 upon 2 x raised power minus 1 upon 2 divided by lambda. Okay, so lambda gets cancelled, we are left with 1 upon, transpose it to the denominator, so its exponent becomes positive is equal to 1, which implies twice x1 raised power 1 upon 2 is equal to 1, which means x1 raised power 1 upon 2 is equal to 1 upon 2, or x1 is equal to, transpose it, it becomes square 1 upon 2 square, which is equal to 1 upon 4. So the value of x1 is equal to 1 upon 4. To find out the value of x2, we plug x1 is equal to 1 upon 4 in equation third. Okay, so which implies 1 minus x1 is this 1 upon 4 raised power 1 upon 2 minus x2 is equal to 0, which is equal to 1 minus, so this can be written as 1 divided by 2 square raised power 1 upon 2 minus equated to x2, which implies 1 minus, so 2 gets cancelled, we are left with 1 upon 2 is equal to x2, subtract 1 upon 2 from 1, so we'll get x2 is equal to 1 upon 2. So x1 came out to be 1 upon 4, x2 is equal to 1 upon 2. That means the correct option should be C option. I hope I make myself clear in this video. Thank you.